We've built and operated ADCS. Now we're going to treat it as a crown jewel. In this module, you'll learn how to lock down CA servers, protect private keys, minimize admin access, and avoid misconfigurations that could undermine trust across your entire domain. You've already designed a solid PKI, deployed ADCS, automated enrollment, and fixed real-world issues using PowerShell and certutil. Now the CA is business critical. Our focus shifts to hardening it, reducing misconfiguration risk, and preparing it for secure, auditable day-to-day operations. A certification authority is effectively the root of trust for your organization. Every certificate that devices, users, servers, and applications rely on ultimately traces back to it. If someone steals the CA's private key, they can mint perfectly valid certificates, impersonating users, spoofing websites, breaking encryption, and bypassing authentication across the environment. So CA hardening isn't just server hygiene. It's about protecting your entire identity infrastructure. Your CA is only as trustworthy as the server it runs on. Treat it like sensitive infrastructure, not a general-purpose box. Start with a hardened Windows baseline and keep it consistently patched through a controlled change process. Strip away every non-CA role, feature, and background service. Lock down who can log on and how they manage it. And never host file shares, web apps, or random tools on this machine. A chaos should behave like a locked vault, not a shared utility server. Only domain controllers and authorized management hosts should be able to reach it, using the specific ADCS and admin ports it actually requires. Everything else, general client networks, internet traffic, and broad RDP access, gets blocked at the firewall. Admins connect through a secure jump server or privileged access workstation, so management traffic is tightly controlled and auditable. Administrative access to a certification authority should feel exceptional, not routine. Define a very small, explicit group of PKI admins and give only them local logon and RDP rights. Require them to use privileged workstations or hardened jump servers, never everyday laptops. Layer in multi-factor authentication wherever the path supports it. Then continuously monitor interactive and failed logons and any changes to those privileged groups so misuse is detected quickly. Certificate authorities must be protected, but they also must be stable. Run antivirus and EDR on CA servers, but follow your vendor's exact exclusions for ADCS binaries, logs, and database files. Keep exclusions as narrow as possible. Overly broad paths become blind spots attackers love. Each time you update an agent or policy, verify that CA issuance and publishing still work as expected. Also remove or disable non-essential services to shrink the attack surface and simplify operations. Think of the CA private key as the organization's master seal. Anything stamped with it is automatically trusted by systems and users. If an attacker gets that seal, they can issue perfectly valid-looking certificates for fake servers, fake users, even malicious code. At that point, every trust decision can be wrong. Fixing this often means replacing the CA, reissuing certificates, and cleaning up trust stores, which is painful and risky. This is why multi-layer protection of that key is non-negotiable. When CA keys live in software, you're really trusting the entire Windows platform around them. Hardening the server, locking down file permissions, and securely configuring the crypto provider all become part of your key's security boundary. Keep local admin membership as small and controlled as possible. Use strong algorithms and key lengths that align with the CA's lifetime. And treat backups as sensitive. Protect system state, registry, database, and key files end-to-end. A hardware security module is essentially a hardened safe for your CA's private keys. Instead of keys living on a server's disk, they're generated and kept inside the device, and all signing happens there. That means attackers can't just copy the key, even if they gain admin access to the server. The trade-off is cost, operational complexity, and careful planning for redundancy and recovery. Smaller labs may skip HSMs, but high-assurance environments almost always rely on them. Think of a CA backup as a complete copy of your authority. If an attacker gets that copy, they don't need the live server. Encrypt every backup that might contain private keys or HSM material and store the passwords in a separate, well-protected system. Keep backups in tightly controlled locations with logging and separation of duties. And rehearse your recovery process in a lab so you're not learning under incident pressure. Role separation means different people own different parts of CA operations. One team runs the CA service, another approves certificate requests, another handles backups, and another audits activity. No single account can bypass every control. Least privilege means each role gets only what it needs. Specific PKI security groups, not broad. Domain admin rights. Keep these groups tightly scoped, use separate admin accounts, and review who's in which role as part of your regular governance. Think of CA administrators as infrastructure owners and certificate managers as workflow owners. CA admins control configuration, security settings, and who can do what. Misconfigurations here can compromise the entire PKI, so access must be extremely limited and monitored. Certificate managers handle day-to-day issuance and revocation. Their permissions should be tightly scoped, especially for high-value templates, and backed by documented auditable approval processes for sensitive requests. Backup operators and auditors both protect the CA, but in very different ways. Backup operators handle highly sensitive recovery material, so their rights must be limited to creating, storing, and restoring backups, nothing more. Auditors need broad visibility into logs and configuration, but no ability to change them. That separation of duties creates checks and balances, and periodic access reviews ensure people still hold only the PKI roles they actually need. Everything in your PKI rests on the CA. Harden the server, limit access, and keep it patched. Guard the private key and backups like crown jewels. Separate duties and enforce least privilege. In the next module, we'll design secure certificate templates, then tackle misconfigurations, auditing, governance, and Azure hybrid PKI.